In this video, we will discuss solving equations containing one absolute value expression. The equation, the absolute value of x equals 5, has two roots, positive 5 and negative 5. To solve an equation that contains an absolute value term, we must examine each of two cases. One case is when the expression within the absolute value term is positive. The other case is when the expression within the absolute value term is negative. Recall that the symbolic definition of the absolute value of a number is the absolute value of a equals a for a greater than or equal to 0, and the absolute value of a equals negative a for a less than 0. To solve an equation containing one absolute value expression, first, isolate the absolute value expression on one side of the equation. Then, separate the equation into two cases. One case considers the expression when the absolute value symbol within the absolute value symbol to be positive. The other case considers it to be negative. Third, solve each case to obtain the two roots of the equation. The absolute value of x equals b has no solution if b is negative, that is, if b is less than 0, and the absolute value of x equals b has one root when b equals 0. For example, find the roots for the equations a, absolute value of x minus 4 equals 7, and b, the absolute value of y plus 3 minus 5 equals 6. If the absolute value of x minus 4 equals 7, then either x minus 4 equals 7 or x minus 4 equals negative 7. If x minus 4 equals 7, then set x equals 7 plus 4, which is 11. If x minus 4 equals negative 7, then x equals negative 7 plus 4, which is negative 3. The solutions are negative 3 and 11. If if the absolute value of y plus 3 minus 5 equals 6, then the absolute value of y plus 3 equals 11. If the absolute value of y plus 3 equals 11, then either y plus 3 equals 11 or y plus 3 equals negative 11. If y plus 3 equals 11, then y equals 11 minus 3, which is 8. If y plus 3 equals negative 11, then y equals negative 11 minus 3, which is negative 14. Solutions are negative 14 and 8. Solve the equation absolute value of 2x minus 5 plus 14 equals 7. If the absolute value of 2x minus 5 plus 14 equals 7, then the absolute value of 2x minus 5 equals 7 minus 14, which is negative 7. However, the absolute value of a number is always greater than or equal to 0. The absolute value of 2x minus 5 cannot be equal to negative 7, so there is no solution to this equation. An equation containing one absolute value term can be written as a function and graphed using the table of solutions method. We can rearrange an equation so that one side equals 0 and then write in function notation the absolute value of x minus 4 equals 7. So the absolute value of x minus 4 minus 7 equals 0. The resulting function is f of x equals the absolute value of x minus 4 minus 7. To graph an equation containing one absolute value expression, first rearrange the equation so that one side equals 0. Then write the equation from step 1 in function notation. Determine the value of x inside the absolute value symbols that will make the value of the absolute value expression 0. Use the value of x found in step 3 and other values of x that are less than and greater than the value found in step 3, and prepare a table of solutions with at least 5 solutions. Then draw the graph using the table of solutions. So for example, graph the function f of x equals the absolute value of x minus 4 minus 7 using the table of solutions method. Steps 1 and 2 of the procedure are already completed. In step 3, we determined that the value of x that will make the value of the absolute value expression 0, the absolute value of x minus 4 equals 0 if x equals 4. So we use 4 as one of our values of x and create the table. We use the values of x, negative 3, 0, 2, 4, 6, 8, and 11, which correspond respectively to 0, negative 3, negative 5, negative 7, negative 5, negative 3, and 0. The graph of the function is shown on the next slide. Here's the function, and each of the dots represents one of the points that we found on our table. The remainder of the section deals with solving inequalities, which we will not address in this class.